Assalamualaikum dan salam sejahtera. Okay, on this video, I want to discuss how to identify which is the molecule, polar molecule and non-polar molecule. Okay, so on this video, I give three example. First, bromine molecule. Second, CH3Cl, and example 3, CCl4 or tetrachloromethane. Okay, there are three elements that we have to consider, okay, to identify which is the molecule are polar or non-polar. Okay, first, student have to draw the Lewis structure for each molecule. So Br, okay, this is Lewis structure for bromine molecule. Okay, and this Lewis, okay, the first element is we have to consider the polar bond. Polar bond, okay. If you refer on the data booklet, okay, how to identify the polar bond, we have to measure the electronegativity difference, and of course the electronegativity difference is zero because both atom is same. So if zero, this is non-polar. Okay. So any molecule that have zero electronegativity difference, this is non-polar. If non-polar, meaning that it exists as polar molecule. Okay. It exists as polar molecule because there is no polar bond. So it just exists as non-polar molecule. Okay, another example for non-polar molecule is H2, uh, F2, Cl2, O2. Okay, all molecule, okay, that have same that bonded to the same element is non-polar. Or maybe the element are combined with another type of atom such as CH4. Okay, carbon are surrounded by same atom which is hydrogen. Okay, it also exists as non-polar because the force is same from all direction. Uh, okay, example 2, CH3Cl. Okay, CH3Cl. Okay, carbon at the center, hydrogen, hydrogen, Cl. Okay. Alright. So in this case, okay. In this case, hydrogen and carbon is 0.4. Okay, this is non-polar bond, but between carbon and chlorine, this is polar bond. Okay, you can refer on the tablet. Yes, of course, it polar bond. If polar bond, okay, polar bond. First, okay, the element that we have considered is it have polar bond? Yes, it have polar bond. Second, if the molecule have polar bond, it have dipole moment or not. Yes, of course. The molecule that have polar bond, it have dipole moment. Where is the dipole moment? Dipole moment is from carbon to Cl. From carbon to Cl. Because Cl is partial negative, carbon will become partial positive. Okay, third element that we have to consider, okay, symmetry. Okay, symmetry of the molecule. Okay, in this case, there is non-symmetry. Non-symmetry. Why non-symmetry? Because the dipole moment is just exists in between carbon and chlorine. There is no dipole moment carbon to hydrogen. right? So there is non-symmetry. Symmetry must have a same dipole moment to all direction. Okay, but in this case, the dipole moment just exists in between carbon and chlorine. So if the molecule have polar bond, have dipole moment, but non-symmetry, it will exist as polar molecule. It exists as polar molecule. Okay, example one, non-polar. Okay, for the third example, we draw the Lewis structure. Okay, Lewis structure. Okay, yes, if you refer on the data booklet, okay, data booklet, CCl is polar, is polar bond. Okay, calculate the electronegativity. Calculate the electronegativity difference. Okay, so carbon and chlorine is polar bond. Polar bond. So let's we refer on the three elements. Okay, first polar bond. Is it have polar bond? Yes, it have polar bond from carbon to chlorine. From carbon to chlorine. Yes, have polar bond. Second, it have dipole moment. Yes, it have dipole moment. Okay, polar bond. If your calculation about the electronegativity difference, dipole moment is the direction. Okay, direction of the attraction sharing electron. This one. This is sharing electron. Okay, okay, the presence of polar bond meaning that it have the pull moment. The pull moment is attraction of electron towards another atom. So in this case, electron are attracted to the chlorine from the carbon. Okay, and dipole moment is occurs in all direction. Okay, on the all direction to the surrounding atom. So is it symmetry? Symmetry. Yes, symmetry because the dipole moment exists in all direction. Okay, from right, left, upper, and the bottom of the carbon. So if it has symmetry, this symmetry can cancel out. Okay, can cancel out the dipole moment. Out the dipole moment. Dipole moment. Okay. Even though it have a force of attraction, but because of the force of attraction is equal to the right, left, to the top and the bottom, okay, we can assume that the dipole moment is cancelled out. If the dipole moment is cancelled out, so it will exist as non-polar. Okay, non-polar molecule. So even though it have polar bond, dipole moment, but its symmetry, it cancel out the dipole moment, it still exists as non-polar molecule. Okay, so this is just a few tips how to identify the dipole and the polar and non-polar molecule. Thank you.